Hello and welcome. In this presentation, we're going to look at part 2 of topic 4, where we discuss various options for estimating the generalized functional z of t. Now, just to recap from our last presentation, we consider a time delay system, a linear time delay system with a constant time delay. And with our decomposition of the unknown input, we obtain a reduced order time delay system, which is disturbance-free from the unknown input. And the unknown input itself is expressed in its simplest form, where we only use the first derivative of the output measurement y1 of t. Now, if this is possible, then we need to have the matching condition regarding this output measurement y1 of t and the disturbance d of t. So in other words, C1 times D would give us a non-zero element, which we call it alpha 1. So that's what happened in the last presentation, part 1 of topic 4, where we consider the decomposition of the unknown input in its simplest form. Now, the significance about this finding is that the functional is now a linear combination of the stack vector x bar 1 of t and a linear combination of the delay stack vector x bar 1 t minus tau. So that's what we call it a generalized functional. And so if we want to asymptotically estimate this unknown input, then we need to realize the estimation of this generalized functional. And so in this presentation, that's what we're going to do. We look at what are the options available for estimating this generalized functional. Now, a little bit of background into this problem. When we first started uh, to investigate in this problem, that was more than 2 years ago. At the time, we did not find any method available in the literature where we can estimate this entire generalized functional directly. So that's the important point that we like to point out. At the time, there was no method available to our knowledge. The only, there are methods available which allow us to estimate the entire stack vector x bar 1 of t of this time delay system, or there are methods which allow us to estimate a functional of this stack vector x bar 1 of t, but not estimate the entire thing directly. And that's why this is the generalized functional. There was no method available yet. So at the time, when we faced this problem, so we started to do a bit of like investigative research into it and what are the options available. And that what discussed in chapter 4 of our book. In chapter 4 of our book, when we arrive at this decomposition, we explored what are the possible options for realizing the functional, generalized functional, which is basically a combination of the two terms in there. Okay, so that's what we did 2 years ago, and in this presentation, would like to give a background to it, and then give us more insights into the importance and the significance of estimating this generalized functional directly. Okay, so let's look into chapter 4, and we look at some possible options for realizing the generalized functional. And we also, on top of that, when we look at various methods for estimating the stack and the functional of time delay system, we also provided chapter 10. We give a comprehensive review of all the available methods available uh, with various structure, where various types of observers. And then finally, estimating the generalized functional directly is the way to go. And that give rise to a lot of investigative research, expository research that we undertook to arrive at all the results that we present in this new book. Okay, so when we look into this generalized functional, at the time, there was only methods for estimating the entire stack vector or a linear functional of it, but not the delay one. So when we investigate this problem, then we say, okay, what are the options available? And of course, the first option that came into our mind was, why don't we just design a minimum order stack observer to estimate, asymptotically estimate this unknown stack vector. And of course, if we can do that, then realizing the generalized functional can be done by simply replacing x bar of t by x bar hat of t. And then what happened there is we're going to delay this estimation of x bar 1 of t by tau. So this is the important bit. We're going to delay it by tau. And then once we delay it by tau, we then can realize this term as well. And as a result, we can realize the generalized functional, and then that would then be able to be used for the asymptotic estimation of the unknown input. So when you look at that, that is one possible option. Yeah, one possible option. And that one possible option is based on existing stack observer for time delay system, which is this system here. Get that estimation x bar 1 of t, we call it x bar hat 1 of t, which is this one here, which is this one in here. And then the important thing about we want to stress here, we have to delay it. We have to delay it. And then realize this term, which is a linear combination of that delay stack vector. This is also another linear combination, but the thing here is we estimate this one first and then realize this bit. Of course, this option is similar to the one that Howe and Muller did with our time delay system. We know that it's the order for estimating this vector, entire vector, the order is n minus p if it exists. But there might be possible functional observers that would give us lower order than that. Or even when we do the estimation directly, that might give us even a lower order than that. So this option itself, even though it's so reasonable, it does not give us a good simplified observer scheme for the unknown input estimation. The other thing that is also very important to mention in here is sometimes when we want to realize a delay functional or a delay functional of the stack vector, and if we estimate the stack vector itself and then try to delay it later, it doesn't work as well. So it will be shown in a numerical example um, in topic 5 part 2, where we show that if we estimate the stack variable or the stack vector, the instantaneous of it, it doesn't work for a time delay system. That observer does not exist, or we get an unstable observer. However, an observer exists where we can estimate that delay stack vector directly. So you see that the significance of having a method where we can realize it directly is a better way of doing it. If for some reason we in our decomposition, if for some reason in our decomposition that term there is 0, and we want to estimate that thing there, and if we do the estimation of x bar 1t first and then delay it, that might not exist. That observer might not exist. And we will show that in a numerical example later on in topic 5 part 2. All right. So let's just move on. So we have an option, which is a straightforward option. And that option simply tells us that if we estimate the anti-stack vector first, and then we delay it, and then we be able to realize the generalized functional. So this is option 1. And again, we know that it's not a very good option. So at that time, we said, look, let's try to look for other options that can give us a much better outcome in terms of the simplicity in the observer that can be used to estimate the generalized functional. So we then extensively looking at option 2, and in the option 2 we have 4 scenarios, 1 by 1. And so this is just an explanation of what we actually did in there. So all the options, scenario 1, 2, 3, and 4 belongs to option 2. And the way we do that is we say, look, let's zoom in into these matrices, A bar 2, 1, I bar D 2, 1. And these are submatrices of the decomposition of the global matrix once we apply the stack transformation matrix. Okay. And in the decomposition itself, bear in mind that the matrix C tilde 1 is of the canonical form. All right, it's of the canonical form. So somewhere along that way, we show that this is of the canonical form. And because it's in the canonical form, so some of the stack variables in there belong to the output measurement. And that's the idea behind that. So what we do in here is we're going to further partition this row matrix I bar 2, 1 into 2 submatrices or into 2 parts. Now, my apologies for the abuse of notation in here. So that is basically telling you that the matrix here is split into 2 bits. The first bit is of dimension 1 by p minus 1. Because the output measurement matrix C1 tilde here is of the dimension p minus 1 by n minus 1. So this measurement vector itself is of dimension p minus 1. And so what we are telling here is let's split this row matrix into 2 parts. The first part of dimension p minus 1, and the other part dimension n minus p. Now, why do we do that? The reason for that is because the first part of that contains the output measurements, y bar of t. And therefore, this sub row matrix associated with the unmeasurable variables related to the stack vector x bar 1 of t. Okay, so the same thing for this row matrix. Again, we split that into two sub row matrix. The first one is of dimension 1 by t minus 1. Again, that will collect the delay output measurement vector y bar of t because of this special structure of C tilde 1. All right, so that was the idea there. We split them into sub row matrices, and with the hope that when we look into with the aim that when we look into realizing this generalized functional, we will then be able to get the most simplified estimation for it. That's the idea behind it. Now, when this term is 0, this submetric is 0, that means that this combination of the stack variable x bar 1 of t is it's in fact the output measurement combination of the output measurement vector y bar of t. So that's what we say in here. That's either the case when that bit there is 0 and the other sub row matrix here is 0 as well. So we then say that, look, this term is this term here. We're replacing that because it's y bar of t. And y bar of t is v2y of t, which is the available output measurement. And similarly, for that term in there, it's just a linear combination of the output measurements. So in that situation, scenario 1 simply tells us that we don't need to design any functional observer or any observer because the unknown input, the t, can be obtained directly from all the available output measurements and the delay output measurement, and also the first derivative of one output measurement. All right, so of course that scenario is the simplest case. And by the way, when we normally design functional observer, we normally assume that this matrix and the C tilde matrix, they are of full rank, but in this situation, they are not. And that's why by exploiting that structure, we're able to realize the estimation directly without needing any observer. Okay. So that's what explained in scenario 1. So there is no need to design an observer to estimate the unknown input. Now, we also went a little bit further than that, and then we exploit the arrangement of the relationship between this matrix, row matrix equal to 0, and this row matrix is 0, and how they are linked to the original matrix A and the original metric ID. And we show that these two relationships, they are equivalent to that. So what happened in here is when we look at the original metric I, and when we partition according to the first row, which is this element here, and this row matrix here, which of dimension here, that one then be further partitioned into submatrices. And then all we do is we can simply look at that submatrix. And if that equal to 0, that is equivalent to that one. So that is another way to just quickly allow us to quickly establish whether we need an unknown input observer, whether it can be directly obtained from the output measurement without the need for any stack of functional observers. Okay, so that is the simplest case, the one that allows us to split the submatrices, and then by just simply looking at that, we then say, oh, to realize this generalized functional, we don't need to estimate anything. Now, of course, in reality, that's not always the case. So we then further to look at another scenario. Another scenario is when we zoom in into this submatrix or this row and this row. And then we say, look, what happened is if that row is not zero, but this one is zero. So in other words, when we look at these two terms, that one is non-zero. But this term here has this sub-row matrix 0. So that means that we don't need to estimate this term because it's just a linear combination of the delay output measurement y bar of t, whereas this thing contains the unmeasurable sub matrix, no, sub vector. There are something there not available, and that where in scenario 2 we say, look, in that situation, or when that term is 0 and this sub row metric is a linear combination of that. So when it is a linear combination of that, we just simply need to estimate this linear function, and then what we do is we can then realize the other one. So this is called scenario 2, where we again we just try to investigate, exploit the inside structure of matrices A bar 21 and A bar D21 to enable us to use existing functional observer, because the existing functional observer methods in the literature at that time, we only able to estimate a linear function of the instantaneous stack vector. There was no discussion about how to realize this term directly. Okay, so it's important to put that into perspective. So when we did that investigation, that's what we say. All right, let's exploit the structure of those submatrices, and then we come up with this this functional observer. And of course, when we come up with that functional observer, which is scenario 2 of our option 2, then what happened in there is it's just a matter of designing a functional observer of the disturbance-free time delay system. And that can be done. There are existing methods, observer structure available. They can range from the structure, for example, which is without internal delay. In other words, there is no ND omega t minus tau in there. So this structure is the seamless structure. It's when we investigate the error conversion of this observer, the error dynamic equation is in terms of this the stability of this matrix, and this is called the observer without internal delay. Of course, there are matrices that we need to find, and in the literature, there are methods available. And in fact, we also present all the existing results in chapter 10. So the idea here is then we need to estimate this functional. It's not the generalized functional. It's the function that is come from exploiting the structure of submatrices, and then imposing, looking at whether these conditions satisfy or not, and that if that's the case, we only need to estimate one linear functional observer to realize the unknown input. So that's the story behind that. And of course, all of these things about observer design and all that, they are well known, so we can skip that bit. On the other hand, when we introducing an observer with this extra term in there, this will relax the observer matching or observer conditions, existing conditions for functional observers. but it lead to the requirement to establish the asymptotic or exponential stability of a time delay system, which then can be realized using LMI techniques and so on. So that is option 2. And when you look at chapter 4, we look at examples and all of that stuff just to tell that we can actually realizing the unknown input, estimate the unknown input using various structures by exploiting different options. Okay. Now, when we then, so you can have a look at that chapter 4 in there. And then when we look at the other option, the other scenario is where scenario 3. Now, in this scenario, what happening is the submatrix A bar 2, 1, and they are not linearly dependent. They are non-zero. They're non-zero. So in other words, that means that we have to realize this functional and this functional. Now remember, at that time we didn't know how to do them all together. So we then say, look, in the case where this row matrix is independent, non-zero, and independent from this row matrix, this row matrix is also non-zero and independent. So that means that we have to realize that term and this term by a functional observer. Now, remember, we did not know how to realize a delay stack vector, a linear functional of a delay vector like that. So what we can do is we can realize this functional there and this functional itself, and then we delay it. So that's what option scenario 3 is about. So effectively, there are two functionals, functional observers. One is to estimate this functional, and the other one is to estimate this functional, but then after we realize it, we have to delay it. Now, the thing about this bit is that we can actually do a bit of a clever rearranging. So when we estimate the two functionals itself, we do one big functional observer where we stack these two functionals together, and therefore instead of just having one row, we have two rows, and then we call that is a new matrix, and then we realize this functional with two dimensions, with two functionals in one go. So it's no longer a scalar functional observer, but it's going to be multiple functionals, and the theory for that it can be applied very straightforward, available in the literature. And then once we realizing this bit here, then that can be realized. So this is how the realization of the generalized functional is done at that time, 2 years ago or more than that. And remember, with the perspective from the historical perspective, that was the methods available at the time. So we're exploiting all possible options with the idea of getting a simplified structure for our unknown input observer. Okay. And then there are examples on how to do all of that stuff. So that is scenario 3. And of course, in here, we're going to look at another motivation for estimate this functional directly. And what happened is the author option scenario for discussed in this book is basically telling that, look, there must be a method. There must be a method that enable us to generalize this functional directly for that reduce the time delay system. And that leads us to a lot of investigative research in the last 2.5 years, and we successfully came up with some methods, and we enable to estimate the generalized functional directly. Okay, so that the story behind that, and that is the scenario 4. So in this chapter 4, the idea there is we decompose the unknown input in its simplest form, and then we explore different options available to realize this generalized functional, bearing in mind that there was only methods available for estimating the entire stack vector directly, or a linear function of it. And so we exploit in all the available options. One option is to not use any functional, and that only occur when some of the structures in this matrix here are 0, and then if some of them is non-zero, and so on. So we got various scenarios. Now, the one that I like to reinforce on is this scenario, which is the estimation of the generalized functional using a generalized functional observer to directly estimate that. To just to give the audience a little bit of motivation behind that. So we go into consider a numerical example where we got matrix ID, which is associated with the time delay vector. And this is the determined matrix, and this is the C output measurement matrix. We had 2 outputs, and we want to estimate an unknown input, D of T. And of course, when you take C times D, we got the answer 1 and 2, which is non-zero. So we can pick an output measurement, let's say output measurement Y1 of T. And then when we do it, we obtain a decomposition, which is based on our existing decomposition technique in the previous topics. And then we obtain the following disturbance-free system. So we got a reduced order time delay system with the metric A bar 1, 1 and ID bar 1, 1, as well as the reduced order output matrix, which is a canonical form 1 and 0. And the key thing about this is that when we do the realization, we have matrix A bar 2, 1 is 0. A bar 2, 1 is 0. So what that means is this generalized functional, that term is 0. So the one that we want to estimate is in fact related to estimating this delay functional here. Okay, so when we look into it, we obtain this unknown input. Now, when we look at this unknown input, there is a need. There is the need for us to estimate this delay functional directly. Remember that if we can estimate directly, then this unknown input can be estimated. So we want to estimate this delay variable directly. Now, the issue with this thing here is that if we don't know how to estimate directly, and if we want to use whatever available options at the time, that means that we have to estimate this unknown variable, this unknown vector instantaneously, and then delay it, and then obtain the estimation for this functional. Now, when we look at this row matrix. It's basically 0, 1. So what happened in here is that contain the second stack variable of the stack vector x bar 1 of t. All right. So the thing about this is that when we go ahead and design an observer to estimate that unmeasurable first. Yeah, because at the time there was no techniques available that tell us you can estimate a delay unmeasurable stack vector. What you have to do is you estimate that first and then delay it, and then delay it. Now we show that later on in topic 5, part 2. In fact, when we want to design an observer to estimate the unmeasurable stack variable of this vector, which is this one here, there is an unstable fixed mode. In other words, existing stack observer design method available in the literature for time delay system. For this time delay system, if we employ, like, for example, an observer without internal delay, then we are in trouble. We get an unstable observer. We can't estimate, we cannot estimate this unknown stack variable because we get an unstable observer. And also if we want to employ an observer with an internal delay, for example, then we can have a stable aerodynamic equation, but it doesn't work for an arbitrary large time delay. So there is another problem in there. So what I like to say in here is, when we face with this situation, even according to this unknown input, we have to realize the estimation of this function. And if we realizing the unknown variable instantaneously, which is that unknown variable, then we are in trouble. We are really in trouble because we couldn't do it. So the idea, like in option 1, where we say, oh, in option 1, where we say, okay, if you estimate the stack vector, unmeasurable stack vector first, and then delay it to realize this, that option is no longer possible for this particular example. All right, so that is very intriguing when it comes to time delay system. All right, and then therefore we have to find another way of doing it. So this is the summary. So if we want to realize this by first design an observer to estimate that, and then delay it, to realize it, it doesn't work. But we can actually directly design a delay stack observer. Now, what would you mean by a delay stack observer? Now, a delay stack observer is that when we come up with it, we estimate. And there are methods which we develop based on stack transformation approach and all of that, which I will go over in a numerical example in part 2, topic 5. Now, that means that when we actually want to realize something that a combination of that, the metric, the functional observer should be estimated directly. Okay. So in this situation here, in chapter 13, where we extensively looking at design generalized functional observer for generalized functional, we can estimate this directly without the need to estimate this vector x bar 1 t first and then delay it. Okay, so that's the important message there. And if we do that here, using that results, we can then be able to realize a delay stack observer with arbitrary dynamics we can assign to it. So the difference there is the distinct difference here is when we want, for this particular example, when we want to estimate this function, this unknown variable, stack variable, first, instantaneously, we can't do it because there is a unstable fixed pole at one. So we got an unstable observer if we employ an observer without internal delay. As well, if we employ an observer with an internal delay, it still doesn't work for any large value of time delay. And so the option of design an observer to estimate first and then delay it and then realize it is not possible. But whereas we can actually, in the development in a generalized observer in chapter 13 allow us to estimate where we pick the metric FD itself is 0, 1. And we can estimate directly. Okay, so all of this was reported in our books, chapter 5. I don't know whether chapter 5, but actually chapter 4, sorry. Okay, chapter 4. So in summary, in chapter 4, we introduced the idea of estimating an unknown input for a class of time delay system. And the thing about this chapter 4 is that we show that we can realize the decomposition using our existing unknown input decomposition in the previous chapters. And then the key thing in here is we get a reduced order time delay system with our unknown input in there. And the unknown input itself is realized as a linear combination of the instantaneous stack factor and linear combination of the delay stack factor. So we call that whole thing there is the generalized functional. And we demonstrate various options for estimating that generalized functional, varying from estimate instantaneously the unknown stack factor, the entire unknown stack factor, and then realize it through this combination. We delay it, and then we realize the generalized functional, the estimation of it. As I said before, this is not a very good option. And then the other option is basically exploring the structure of the sub matrices. And with at the time, the tool for us is only estimation of the stack vector or a linear function of the stack vector without any delay stack vector in there. And that's why we had to investigate it that way. And then later on, we come to the conclusion that we must develop new methods, techniques for realizing the generalized functional directly. Okay. And so that basically conclude our discussion on unknown input estimation for time delay system, and it points us to the importance of being able to realize the generalized functional directly. In topic 4, we basically explaining that when we deal with time delay systems, unknown input decomposition, we will come up with generalized functional. And then there is a need to develop generalized functional observer for time delay systems. And so topic 1, we look at a symbol time delay system. We show that we can realize the decomposition in this way. Now, in the next in the next topic, which is topic 4, part 3, we going to further show that or demonstrate that we can do the decomposition using our metric decomposition technique for a class of time delay system where we're going to have delay term occur in the output measurement. And again, we will show that when we do all of that stuff, we're going to realize, we're going to arrive at generalized functional. So I like to demonstrate this important thing in there later on in the next topic. We will get generalized functional. The generalized functional, we will get the reduced order time delay system. Sometimes it might contain up to multiple time delay terms, multiple delay terms in the output measurement. And also the realization of the unknown input is also resulted in generalized functionals. And so it showed that very clearly when we are dealing with unknown input estimation for a more complex class of time delay systems, inevitably we need to design generalized functional. We need to design generalized functional observer for time delay system with multiple time delays. And that is the novelty of our result in this book. We introduce the concept of generalized functionals, and we demonstrate that, look, that came from the unknown input estimation problem. Without actually looking at this kind of metric decomposition, unknown decomposition, we would never arrive at this kind of generalized functional observer. And that's why in the literature, when it came to estimating stack of functional for time delay system, the focus was just simply focusing on just one term in there, but not some of the whole heaps of them. All right, so that's the distinct work about novelty about our results, our discussion in this new book. So thank you very much for watching, and please join me for the next presentation coming up, which is about part 3 of topic 2, no, topic 4, where we look at the decomposition. And it's going to be very intriguing when we look into it. And as I say, we'll come up with generalized functionals. And then that will be enough discussion relating to the point that we want to stress, that you have generalized functionals. So what are you going to do about it? And that's where we going to develop functional observers design methods. And then we're going to demonstrate the significance of that. Okay, so it's going to be very, very intriguing, and it's very exciting ahead. So please join me for the next presentation. And thank you very much. Bye-bye for now.